We are used to the classical model of the Earth's structure. It was described over 100 years ago: a metallic core, a silicate mantle, and a thin crust. Although this model is well established and included in textbooks, it cannot sufficiently explain many facts, experimental results, and phenomena that have occurred and continue to occur on Earth. In this video, we'll look at an alternative model of Earth's structure and figure out where giant hydrogen reserves are hidden inside our planet. At the end of the last century, Russian scientist and geologist Vladimir Larin proposed a new hypothesis and model of Earth's structure. In his model, the core is not metallic, and the mantle is not composed of silicates. If hydrogen is the most common element in the universe, why would Earth be an exception? According to Larin, most of Earth's hydrogen is not in the oceans or atmosphere, but in its core. But how could so much hydrogen be stored there? So how and from which elements was our planet formed? Of all the elements of the universe? No. It doesn't match their ratio in the Earth's crust and mantle. From meteoritic material? Also no. Their composition differs significantly from Earth's. The answer was found thanks to astrophysicist Fred Hoyle's idea of the determining role of the magnetic field in the formation of the solar system. The primary interstellar nebula after the supernova explosion lost stability, began to compress toward its center of gravity, and as it compressed, it rotated, stretching out into a disk, a giant plasma disk. The rotating plasma generated a magnetic field that began to work like a giant separator. It stopped charged particles and let neutral ones through. The elements were distributed according to their ionization potential. So each planet had its own composition of elements. Most of the hydrogen was left on the Sun, but quite a lot went to the part where the Earth formed. What happened next? As the planet compressed, internal pressure increased. Finally, metals and hydrogen under compression formed hydrides. Based on this hypothesis, modern Earth should have the following structure. A hydride is a chemical compound in which hydrogen atoms are embedded into the crystal lattice of a metal. In this case, one volume of metal can accommodate hundreds of volumes of hydrogen. And today, this hydrogen is released from the core as a gas, moving through the Earth's mantle outward. A tiny fraction of this amount is enough to meet all of humanity's energy needs. The transition to hydrogen energy is inevitable, as is the modernization of many sectors of the economy. A time of great changes is coming. The era of hydrogen is approaching.